Welcome back. So now that we understand the concept of Bulletsolver, let's actually build something with it. This sphere is a live interactive object. I could put a slight rotation on my shape and we can see that we can start to interact with it. But as just happened there, my shape is a single pixel, which means that if I interact with it thanks to its collision box, it means that the circle has a chance of falling through it. So rather than moving geometry a lot, what I want to do is I want to impact forces on my sphere, which means that I can still move my ball without having to worry about collision problems inside my scene unless I specifically engineer them. And to introduce a force, I'm going to go to my comp selector again, and you can see there's two types. We have force, and we have what's called an impulse force. Envision these as a force is me constantly leaning against you, whereas an impulse force is me physically pushing you. After we've loaded in a force, what we need to do is connect them to our object. So I'm going to connect my force 1 and my impulse force 1. And now our actor is ready to accept us leaning on it or us pushing it. So if I give you a practice example of an impulse, I'm going to do an X force of 100, which means that it should move on the positive X axis on 100 with an 100 unit force going to the right. So if I pulse it, you can see that it rolled off the edge fairly gently. And that's because this 100 unit force only existed for a single frame. If I reinitialize it and do it again, you can see that I can continue pulse it, and then we get the interaction we would expect. And that's actually the style of force that the main non-impulse force applies. So if I deactivate it and apply a force of 100 on the x-axis again, but this time activate it, so you can see that this has a much quicker movement to the right, and it continues moving to the right constantly at 100 units of force versus the single jolt of pulse, which gives us a much more realistic force. So what do we actually want to do? Well, I said we wanted to make some sort of rollerball game. So a really simple physics interaction game. Let's have a look at making that. So I'm going to quickly go and manufacture a scene where I'm going to have I'm going to keep this solid plane here. I'm going to make it slightly bigger, and then I'm going to add a little seesaw to it. So I'm going to pause here and I'll explain the result after that. Okay, welcome back. So what I've done is I lengthened my floor a bit. I've still got that infinite. And then I made a tube that is also infinite. And I added a smaller version of my floor that is dynamic, but I gave it a really, really big mass of 100. So it's really heavy and hard to move. I also added a few textures here and there just so it was easier to see things. And our ball is still the exact same as it was before. So it's still a mass of 10, and I have an impulse force of -10 that I can now apply to it. The one thing we've not explored yet, and we need to because obviously we're building a platform game, even though this is a different type of comp, it still works in the same way as a standard 3D geometry comp does. So I can add a camera to my scene, I can move that camera around, and I'm able to get a rendered representation of our network. So if I add a render, and then I add that render to an out, it means that I should be able to activate my panel viewer and look at my main project. Inside here, let's add some light because I added thongs. So I just need to, my lights were inside my B-solver, so I just need to update my render to go inside and actually get it. In here, I'm going to add an ambient light so we can see a bunch of stuff. Let's make it dim. And then I've got my main light that I'm going to make follow my ball. And to do that, I'm going to use the chop that I added. I'm then going to execute it, so I'm going to pulse it. I'm going to go up a level, sorry, and then I'm going to start my simulation. And I just want to see which way my ball is rolling. So it's moving on the y-axis. So I want to link my light's y-axis to my ball's y-axis. And I'm going to have a look at my geometry viewer again just to see what my camera's doing. So I don't think Y was the right option. So it's that. I actually want to change its X rating because my light will now fall. I guess that'll work. So now I want to attach X to X. And you can see my light is now following my ball consistently. I'm going to add an out to this chop and actually do the exact same with my camera. I don't want to constrain or look at, but I do want my camera to follow where my ball is to create a realistic experience. So I'm going to come out here. My camera is also going to be attached to the X and the Y of the ball. So now if I initiate the sim and then start it, we can see that our render, if I go back to panel, is now following our ball precisely from a 2D perspective. We are still working in a 3D environment though. I want to make sure that my ball doesn't stray too far on the Z. So you can see here, if we initialize it, it starts on 0 on the Z. And in the geometry viewer, that means that it's still dead in line with it. Basically, it's rolling on that red line. But the more we move it, the more it changes where it is. So you can see this TZ, it's now almost a whole unit over to the right-hand side. So what I want to do is I'm going to use my consistent force to apply the inverse movement of that transform. So I'm going to activate it. Again, I'm going to reinitialize my ball once more, and my force, I'm going to set its Z to be a negative version of itself. So what it means now, if I reinitialize is it means that the ball will consistently have the opposite force to its current position on the Z applied to it. And all that means is that it should keep it as straight as we're going to get for now. So you can see it should wobble back and forward across the line. But it just means we get some control of the ball. So that's, I took its Z force and then times it negative of itself. Okay, so now I'm going to go back to my panel viewer. That I'm happy with that. I'm going to reinitialize my ball. And before we start, I want to adjust the position of the camera slightly. So I want to move it up a bit, so I'm going to say +10, and I'm going to angle it down towards everything again. So I'm going to say 10 and -10, and I'm going to initialize all again. Let's lift that up. So now it just means that my camera is slightly higher and angled down towards the ball. Let's add a simple button. So I'm going to do a momentary button. I'm going to call it reset. And with a chop execute on to off, what we're going to do is we're going to ask our Bulletsolver, so our Bulletsolver, to reset itself. So we're going to say Bulletsolver1.par.init.pulse. So we're basically going to click here and initialize the sim, and then we're going to start it. So we're going to say operator Bulletsolver1.par.start.pulse. So now whenever I click the reset button, oh, I spelled pulse wrong. I also spelled Bulletsolver wrong. So now when I push the reset button, it will reset everything to its basic position. So you can see my seesaw and the ball move, and it will begin the simulation. I'm going to create a second chop execute and attach it to the actor position for our ball. And I'm going to do on value change. I want to check. So I'm going to say if channel.name is equal to ty, then do something. And then I'm going to say if val is less than or equal to -50, then do the exact same code and reset our simulator. So now if I push reset, Oh, I'm not indented those enough. There we go. So now what should happen when our ball falls off is that it should snap back and reset after it falls past the 50 unit mark, which it does.